Today I want to talk about DJI O3 and specifically remote controllers and using it with the DJI FPV Remote version 2. Now, whilst you might be thinking this is a very nice and quick, easy way to get up and running with O3, there are a few things you need to be aware of, and specifically some things you need to understand with regards to how this remote will behave in signal loss. Now, what we're going to do in this video is give you an overview of what the compatibility is, walk you through the things you need to be aware of, and then at the end, just share with you some thoughts on what my opinions are that you should do with regards to remote controllers. And I'll say up front, I probably wouldn't recommend using this. Now, just before we jump into it, if you find this video useful, please do make sure you are subscribed. I have a whole ream of content on the O3 system. If you're interested in supporting us to allow us to keep making content like this, please do consider checking out the link to my Patreon in the description as well. Anyway, let's get on with it and let's take a closer look at what this remote thing is all about. Okay, so to explain the very basics first of all, the DJI O3 Air unit is compatible with the FPV Remote version 2. This allows you to have full control over your DIY drone with the DJI remote. Just like on the previous FPV system where you had the large black remote, this one now allows you to control the aircraft with the sticks. You have the ability of setting arm in, and you can use the buttons and functions on this remote with your own drone via the built-in S-Bus link in the O3 Air unit. Whilst that all sounds fantastic and it does make for a very clean build, there are a few things that you need to be aware of. Unlike a standard remote setup with the likes of Express, SolarS or Crossfire that rely on their own link, this FPV remote is part of the main OcuSync link. When you first of all need to use it, you need to bind it to the system, and the whole OcuSync setup is actually a form of network with the remote, the goggles and the air unit all communicating with each other. The way O3 actually works is that the air unit will transmit video on 5.8 GHz back to the goggles only. However, the transmission from the remote and the goggles can go to the air unit on either 2.4 or 5 GHz. As a result of this, it should mean that the goggles and the remote link should be able to get better range than the video link that returns from the air unit. Now, the interesting thing about the behavior on the OcuSync system is what happens in signal loss. Whilst the remote and the goggles do have the ability to transmit on 2.4 or 5 gigs, the reality of the way the system works is the second the video signal is lost, you actually drop the control link as well. Over the last few weeks, I've been doing extensive testing on the O3 system, testing it on my spectrum analyzer, and Ken Dobo from Original Dobo actually reached out to me a few days ago asking me about some of the behavior he'd seen, and I've done a bit more of a deep dive into exactly what happens, and I'm going to show you that on the spectrum analyzer in a moment. The very basics of that though are when the video link starts to drop from the goggles to the O3 system, the remote control link starts to drop as well. At the point the video link actually cuts off, the remote control signal to the drone cuts off as well, and whatever your flight controller is set to do with regards to failsafe will kick in at that point. That means there is no ability within this system to continue to have remote link after you lose video signal. Now, that is the very basic behavior of the system, but there is actually more to it than that. And whereas I said you lose the remote signal when you lose video signal, whilst that is correct, something a little bit interesting happens after a period of time of no recovery. What I mean by that is, at the point of you losing video signal, you lose control from the goggles and the remote to the drone. However, if the video signal doesn't return after roughly 5 seconds, the remote seems to change channel and then reconnect to the air unit. The bizarre thing about the behavior of this is what will happen in a signal loss is you will lose control, then after 5 seconds regain control. Now, the reality is, if you don't get video come back on the goggles, you're not really going to know that you've recovered your RC signal, but it is an interesting behavior that you should be aware of. The overall point to take from this is whilst it does reconnect, the basics are when you lose video signal on the O3 system, you're going to lose RC signal as well for at least 5 seconds, and that means your aircraft is going to do whatever the failsafe behavior you have set is. The real downside to this is the fact that in the event of video loss, you don't have the instant ability to try and recover. For instance, if you're using something such as Express LRS or Crossfire, at the point of video loss, you could choose to trigger return to home if you had GPS, or you could do something like a punch out to try and recover video, so you actually then are able to continue to fly back. The fact that the video signal loses with the remote at the same time means your aircraft is going to do whatever the default failsafe behavior is, and you're going to need to make sure that you have that set correctly and take that into account when flying, because you're going to have no ability to react when that happens. What I'm going to do next is walk you through this on the Spectrum Analyzer, just to walk you through that whole behavior, because it is rather interesting. I'm not exactly sure why DJI have it that after, say, 5 seconds of loss of control, the remote changes frequency and reconnects. It may be a form of backup option, but the reality is, for us, with drones that don't have the failsafe features that DJI drones have, you really do have to treat it as when the video drops, the remote drops, and have your failsafe in place to recover from it. Now, just to demonstrate this, here I have a setup where the drone is on the bench set up next to my Spectrum Analyzer. We have the remote sitting a distance away with the sticks moved, and I'm moving the goggles away further and further to the point of where the goggles only will enter signal loss. The remote is still within range of the drone. What you will see happen is, as the signal from the goggles gets to the point where it's about to drop, you will see the input from the RC start to judder and stop. And what you've then seen is the video link drop, and then the carrier move and drop down the thinner standby carrier, which is waiting for the goggles link to reconnect. What's interesting is where you see the point of the large O3 carrier in the middle of the Spectrum screen drop and change, you see the remote link stop as well, but then a few seconds later, the remote link itself recovers. On the remote side, what you had was a couple of beeps to say that the signal had dropped, the LED started to flash, and then a reconnection beep after that 5 seconds. Now, when the remote reconnects, it is highly variable what band it chooses to come back on. Sometimes it comes back on the same frequency it was before, i.e. 5.8 gigs, as you can see here, or sometimes it comes back on 2.4 gigs. The basics are, though, is that once the video feed drops, it has this pause time, and then it will try to re-establish the link with the air unit, connect, and carry on as it was before. Now, just to quickly demonstrate the FPV remote in use, I'm not going to walk you through how to set it up. I've currently got it configured into Betaflight, and you can see the outputs from it on the screen. You configure it exactly the same as you would any normal remote. It's S-bus input. Make sure you've got the correct UART set up. Make sure you've got the ports tab right, and it should show. Then you can see here, we've got our stick inputs. Now, there's no configuration in the O3 system for the remote. The buttons and controls are preset functions. So, for instance, if I just pop the antenna down here, the left-hand switch is AUX 1. That moves between 1000, 1500 and 2000 PWM. The switch on the right-hand side is AUX 2, again, moving through 1000, 1500, 2000 PWM. We then have some momentary latching buttons. So, the pause return to home button up here is a latch-in button that when you press goes down to 1500, press again, goes up to 2000. That is set to AUX 3. We've then got the start-stop over here, which is set to AUX 4, exactly the same. And C1 set to AUX 5. The record camera shutter button up here is pre-configured in the O3 system, and that will start and stop recording on your DVR, on your ear unit, as well as your goggles. No configuration needed for that. But what is nice is that it is basically pre-configured out the box. You just want to set what your arming is, set what your mode is. You can have it on a latch-in one if you want, or set it on one of the switches. Nice and simple and straightforward as that. Now, I've spent a lot of time looking at this, and I can't really understand why DJI have it that the signal recovers on the remote after a few seconds of video loss. The very basics are, though, at the point of losing video, you're going to lose RC, and you have to plan your failsafe settings around that. As a result, I don't recommend you use the DJI FPV Remote version 2 with your DIY drone because you don't have the ability to easily recover in the event of a goggles video signal loss. Whilst there isn't a lot you can necessarily do without video stream, you still can punch out and you could still manually trigger failsafe in the event of a video loss on a normal system, but unfortunately, in reality, you're not going to be able to do this on this. Potentially, you could set your failsafe settings on Betaflight to ignore it for 5 seconds, but that would probably be insanity. It'll probably end up in a hedge or something by then. And personally, I would recommend you go with a standard remote, something like the TX16S with the Crossfire, with Express LRS like I've got here. Having a standalone RC link means you remain in control. And the real good thing is you remain in control. You have the ability to trigger failsafe and you remain in the situation where your RC signal is almost guaranteed to outperform your video signal in pretty much every situation. So that is it. The behavior is a bit strange, but it is now something you hopefully understand and you can plan what you intend to do with your failsafe settings as a result of this information. If you have found this video interesting, if you have any questions, please do let me know what you think in the comment section and I will try and answer it. Furthermore, if you'd like to support the channel to allow us to keep making content like this, please do consider checking out the link to my Patreon in the description. I want to say a massive thank you from me to all of my patrons. I would not be able to keep buying products to make the content that you see here today without their support. And if you'd like to support us to keep doing that in the future, please do consider checking it out. I have a bunch of other content on O3 if you're interested in seeing it. I have a dedicated playlist on O3 now as well, so I'll put a link to that in the description as well. This video will be in that playlist, so for more information, please do consider checking that out as well. Anyway, that's it from me. Stay safe. Let me know what you think in the comments, and I will speak to you soon.